What's up, solderers? So, with our circuit so far, we have already identified our components. We've put them into a stock take. We have already found out how to put some of our components onto our board and the direction of them. Our next step now is we are going to start the soldering. So, before we start even turning on our soldering iron, we have some safety things that we have to double check to make sure. Number one, if you have your safety goggles, wear your safety goggles. If you do not have safety goggles, find some other way to protect your eyes. You do not want any moisture hitting solder and causing it to um, bounce off stuff and go into your eye. In general, when you're also cutting off the ends of your soldering of your electronic pieces, they're going to be flying across the room. They're not going to cause any damage if they hit your skin, but if they go into your eye, it could cause you some damage. Number two, when we looked at our first video, we're already discussing the ideal setup for the location of your soldering iron. For me, my soldering iron's sort of off camera, but it's in this direction over here, so my hand's going to be able to pick it up and it's not going to interfere with the circuit over here. Secondly, so this soldering iron's turned off right now. You'll need some sort of sponge or paper towels with some moisture in it to clean the tip of your soldering iron. This is so it's going to ensure that you get nice clean solders when you're removing all that residue, which is like burnt flux that is inside the solder. Now, this one I did. I put this piece of paper in here, I think it was 2 days ago, and it's already dried up. So if I use this just cinder. It will catch on light and it will be unideal for our soldering situation. So I just get myself some water and I try to pour the water on there. There you go, that should be enough. It doesn't have to be soaking in it. It just has to be damp enough that it's not going to catch a light when you have that hot solder. You don't want to get any burn marks onto the actual liquid itself. And then I'm going to move that water away so it doesn't cause any spilling problems. Alright, so I put my soldering iron, and over here we have the dock. You need some way to have your soldering iron so it's not resting onto the table as you're doing it. So get some sort of a ceramic plate or something that will keep your soldering iron in a safe location. Alright, so I'm going to move this over here into its safe location on the side of the screen. So we are ready to do our first soldering. So up here in the top right, we have an infographic that I found that will assist us in doing our solders. So we have 4 basic steps when it comes to doing our solder. Now, these are just the categories or the headings of the 4 things we have to do. In practice, there is often some more difficulty, especially when you are having to manage the way that you hold the circuit and the soldering iron, and so the steps themselves, they're still the basic things you're going to do, but they are not as quick as they look on the board all the time. Right, so when we start, we're going to heat up the part and the pad. We see that the soldering iron is connected, the soldering iron tip is touching both the copper ring and the part, like if that's, let's say it's a resistor, the metal part of the resistor. It is touching both of those because it is heating up both the part and the pad. Then we're going to add the solder, which is the silver line to the left, the silver squiggly line, and we want to introduce the solder at the junction point. So where the metal rod and the copper pad is, we want to put it at that junction point, and we want to keep feeding it in while we continue to heat it up, and then we're going to get a nice shape of like that cone, not so much a cone. Almost like a reverse funnel looking shape around the part. That means that it has a very, very good connection. The copper's going around and touching the complete part of the pad, and it's also connected. It's also clearly connected to the rod of the component. And then we want to let it cool, and it says there, do not blow. Right. Now we're going to be doing we will be using like a blowing or a breathing technique to allow we don't want the smoke for the solder to go into our face. That is different than blowing on a part to cool it down. So don't get that confused. And then we're going to do some we're going to do some soldering, and then we're going to see that the errors, well, I'm perfect, I'm not going to make any errors, but we might get some errors. I will do it for only demonstration purposes, obviously. But yeah, a perfect solder gives you like that reverse funnel looking shape there. And then we have like the common soldering errors there. We have too much solder. We see that the soldering is going around the part completely. Not enough solder. So you see here we have that sort of funnel shape, but it's not covering the entire piece of the copper. Well, we want to cover the entire copper. It ensures a very, very strong connection. We have the cold joint, which means that we're putting the soldering iron too much. We put too much of the heat from the soldering iron onto the rod of the resistor and not enough on the actual circuit board. So that caused the solder to only want to attach to the resistor part, and it's not actually connected to the circuit board. This will be one that causes a lot of problems why your circuit might not be working, so you might have to redo those joints. Then we have a scenario there where there's too much heat is being applied. Now, obviously the color's darker, and if we can see on that funnel down the bottom, like where it's touching the circuit board, we can see it's like lifting up. Now, the circuit board is a copper. The circuit board, as we've already established, is like a copper or like some sort of metallic surface, right? And then the non-copper parts are being etched out by whatever method, right? And then there's a resin layer on the top. Now, the whole circuit board itself is not copper. The circuit board is actually a form of fiberglass, so that's like some sort of plastic with glass resin to enhance it. So it is not conductive at all. So the copper layer is actually glued. So there's a thin layer of copper, like think of gluing like a layer of aluminium foil, except copper foil, onto a circuit board. If you apply too much heat to that copper, it will actually de-glue itself because the glue will melt or degrade. And so for some parts, like let me just pick a random part of here. For a part like here, that one that my pen's on, if that deglues, right, it's going to be more resistant to degluing because it's connected on like both sides of the parts, which is going to be resting in place. But a part that would be of concern would be a part like this part over here. This one. Part like this part over here, because it is only connected on one side. So if this thing heats up and deglues, it's just going to start lifting up. Especially, so that will happen, and that's going to cause us issues when it comes to getting our circuit to work. And remember, there's components coming in from the other side, and we're actually gluing our components to the circuit board through these individual copper tracks. And if the copper track itself is it's no longer connected to the actual fiberglass, there's actually nothing holding that component down, and that can cause later, it means that if we get vibration or we get other things, it could cause issues. So we have to control the way we're applying heat. Now, if you have a variable solder, you can pick a nice temperature. I'm going to pick 350 degrees on my soldering iron. I find that's a nice balance between getting a job done fast enough and not overburning your components. If you have an unadjustable soldering iron, you're going to have to learn and get used to the way your soldering iron works. When it comes to heating, it's always easy to underheat a component and then add more heat later. Like for example, we have there the cold joint. It's easier for you to get to a cold joint point and then put extra heat onto the copper circuit board, because once you provide too much heat and you break the part, you're going to have to provide some other way of fixing that circuit. And the last mistake, which is the one that causes the most errors, is a short. So we see there we have two copper components. Let's say that circuit could be simulating like these two parts over here, right? So that one and that one. And if I put solder on both of these parts and I actually link that solder together, like in the example of the short, these tracks, even though they're clearly separate, of course the one I'm showing has that right in the way. There we go. These two tracks over here are separate. They're not touching, right? We can see the green marks underneath them, the light green marks representing that there's copper underneath there. They are not touching, but if I solder and I have the solder connected to both the parts, they now are touching. So the circuit is not working as intended. Now this can cause issues as minor as like one of your lights doesn't work, or It could mean your circuit completely doesn't work. That's usually the medium case. But in the worst case, we have resistors in our circuit that we use to control the current flowing around our system. If we short and bypass one of those resistors, we can cause undesirable amounts of current to go through certain parts of our system, and we could actually blow up or permanently damage our system. For example, if we have our LED lights and we have our resistors for our LED lights and we bypass that resistor, the current going through the system will easily destroy our LED lights. So we have to we want to avoid those type of situations. All right, so I'm just going to adjust my stream setup and we can get ready to start soldering. So because it takes some time, now I believe I am in a safe enough position right now to get ready to soldering. So I'm going to turn on my soldering iron. Now, as soon as you have your soldering iron turned on, right, some of you are going to have your soldering iron plugged into your PowerPoint. If you're lucky, your soldering iron will have an indicator. Some of them won't have indicators. So as soon as you put power into your soldering iron, you have to have the mental mind step, or the mental understanding happening that your soldering iron will be hot forever. Right? Until even when you turn it off, it still takes time. Like depending on the soldering iron, it could take minutes to. It could take up to like half an hour, depending on how hot your soldering iron was and what type of soldering iron. If it's one of the gas-powered ones, because there are gas-powered ones that use a heating element of like that burn the metal tip. They can be hot for like up to an hour, depending on the type of soldering iron. So from as soon as you put power onto your soldering iron, you have to assume that that is an armed soldering iron and that it can cause problems onto your system. Sorry, not problems onto your system. That it is dangerous to touch the metal thing. So I've already turned my soldering iron on, and it says it's heating up, which means it's not at the current temperature that I want it to be at, but it itself is getting up to that temperature, so it gives me time to look at my circuit and start to design or plan ahead for what I want to solder. Soldering is similar to whenever you're doing some cooking, where if you have all the ingredients out in front of you and ready, the actual cooking process is fairly simple. You just do one after another. You get yourself into a nice flow. Where you have problems is, I'm going to need some extra light. Where you have problems with soldering is if you're trying to solder individual components and then you're going into other locations to find your parts. So I have over here, I have my resistors. Excuse me. I have my LED lights over here. I have my capacitors. I have my switch. Sorry, my connector. I would have my resistors here, but they're already plugged in here from the last video. I have my 407 resistors, and this over here, this is the part that where it would greatly assist us. I have already divided up my components that are going to confuse me later on, like my 8050 and my 9013s. I already labeled them on the sticker tape here, and I've already written down what V spot they are going to be heading into, so I don't have to have access to my stock take. If you do have your stock take, that's great, use that. Excuse me, just having some drink because we have to remember to stay hydrated in these times. Okay, so we are ready to solder. Let me bring my soldering iron over. Oh, so what you're also going to need is you're going to need some access to some solder. I have a whole roll here. You obviously don't need a whole roll of solder. You can have a small piece of solder. It's just easier for me to grab this, and I don't particularly want to rip it if I don't have to. So let's talk about solder itself. You will have a piece of solder. This over here is, does it say what thickness it is? This is a 0.71 millimeter piece of solder, so it's less than a millimeter. Solder comes in a variety of thicknesses. If you're buying your own solder, you can get 1 millimeter thick solder. I find for my electronic circuits, I find that the smaller solder is the better solder to use. The thin, like the 0.7s tend to be the better solder, not the better, the easier solder to use, because it means you're feeding in less solder into the system, so you can get more control over the amount of solder you're doing. For commercial quantities, like when you're dealing with large gauge wires, that's why they use thicker solder, because you're physically putting in more volume of solder into a joint. So if you have like larger wires, you can put large amounts of solder in there faster. But we don't need that. We actually are using very, very small amounts of solder, so I like the small solder itself. Again, this solder has a lead base in it, so we're going to make sure that we wash our hands thoroughly after we do our soldering, before we do any eating, or even before we touch anything else. We'll just like to wash our hands. And in these times, there is no downside to washing your hands. So, you know, it's good that we already know how to do that. Now, the actual construction of the soldering iron. Oh, let's see if I can get this on the solder. Sorry, let's see if I can get this on the camera. Because, all right, so if you look at my tiny camera over there, you can see that there is actually a hole in the solder. Right, there's a tiny hole. Now, if you look at your own piece of solder, you should see that hole there yourself. Let me just get my where's my cutting implement? I just want to get a fresh cut. So over there, I cut the solder. Now, if you're cutting the solder with a pair of pliers or whatever, you're not actually going to see that hole because you're clamping it down as you're cutting it. But if you break your solder by pulling it, if you do it right, which can't always do. Oh, there we go, to an extent. So let's look back at our solder there. We can see here we got that hole. All right, so this solder is not a solid piece of this solder is not a solid piece of metal. It is actually a tube, and inside the tube there is flux. So what is flux? Flux is, so we have our solder, and solder itself is a metal, and it likes to bond to itself. Right, it's a piece of metal, and it likes to bond to itself. It doesn't like to flow around to other areas. It wants to like collect. And so what the flux is a liquid. It's like an oil-based liquid. Flux is just a generic term to mean something that flows. All right, or like changing. We use it in like electronics to describe the change of flow of electrons, but we're using it in like a more of a mechanical sense. Flux just means to flow. So we have this material in our solder itself. So when we heat it up, it's going to allow the solder to flow around in other areas. We can compare it to an analogy of like surface tension of water. How we know that water has like a surface tension, and when you try to put your finger into water and you pull your hand out, you get like a meniscus. And those are because the water wants to attach itself. But if we add something like a detergent in there, like soap, we don't have that surface tension anymore. So it's like the same thing. Flux is in the solder, so it doesn't have surface tension, so it's going to go and flow around to all our components. And this solder, because it's designed for electronics and for convenience sake, it has the flux already inbuilt, which is fine. That's good. But the downside is that is what's going to be producing our smoke later. It's not the solder that's evaporating; it's the flux, because it doesn't have the same heating point. Well, it can't, because it has to go liquid before the solder goes liquid. So that's what we're going to be blowing it out, or we're going to be doing our exhaling technique, so we don't get the solder fumes in our. So we don't get the solder fumes. I'm gonna have to rearrange this. I might have to put some tape down or something. So we're gonna be dealing with those solder fumes. What if I do this? No, that doesn't work. Bear with me for a hot second. We are gonna tape this thing down, because the problem is my silicon mat. The tape doesn't actually stick to my silicon mat because it's silicon, and silicon's known for its properties of nothing wants to attach to it. So I have to I have to tape my camera down to something else, and this ground camera I have here for soldering is actually a very light camera, like physically by weight, so um, it wants to, the cable hooking up to the computer is actually pulling on it, so it's not letting me get the ideal locations I want, but there we go. Lovely. So when I do my soldering, we're going to get a high-tech soldering situation over here. Beautiful. And let me just adjust my focus so we can see this. Ooh, there we go. Where's that 4K streaming setup we have there? Okay. And we're going to be adjusting that depending on so I can get access to my solder parts. Okay, good. All right. Where were we? Yes, so we have our flux we're going to be blowing out, and if you have solder that does not have flux, typically, for example, solder used for like plumbing, like where they have like copper solder or solder that doesn't use tin and lead, you'll have to apply manual flux to the circuit. But generally, when you go to your average store and you buy solder, it will have the flux inbuilt. Does it mention it anywhere? Well, this one over here, this particular one, this particular solder over here does say it has 2% flux, so we know that it has to have the flux included. But yeah, most if you look at stuff that looks like the stuff that you're seeing in the workshop, that usually has the flux inbuilt. Right, so at this point, my thing is heated up. I already have my resistors in the circuit. As in from our last tutorial, these are my R1s. Sorry, this is R1, R3, and R5. So these are my 10K resistors. I have them in place. I've locked them in so they're not going to fall out anywhere. I'm going to put them down onto my bench. Right, and now I'm ready to go with my soldering iron. Now let's see, can we, in the location you are you going to be able to see me soldering? Yes. So my thing's heated up. I am giving it a clean. If I do this, do you see that exact thing? Oh, perfect. Right, I'm giving my solder iron a tip of clean. So you see that looks like a nice clean soldering iron tip there. Getting myself some solder. So if we follow the steps, the first step of it was got to heat up the pad and the solder for 2 to 3 seconds. So 1, 2, 3, and then I'm adding in the solder. Then I'm removing it. I heated it up for 1 to 2 seconds, and then I let it remove and I let it cool. So let's have a look at our first solder and see what's happening here. So the actual soldering joint itself, right, we see we have part of that funnel action. Now my in this scenario, the first one, my foot was bent out. We see I'm not going to get that perfect like reverse funnel shape onto it. I'm actually going to straighten up my other lines to see if that can give me the perfect shape. So we're going to try that again. Clean my solder. And so I have to do it fast because I have like 5 seconds to do this, so unfortunately I can't go through it slow, but I'm going to heat it up for 1, 2, 3 seconds, and I'm going to add my solder. I'm going to continue heating it for another 2 seconds, and then I'm going to remove my soldering iron. So 1, 2, 3. Put my soldering iron away. So there we go. So we can see I have that reverse funnel shape. I almost, because it's not as curved as I want it to be. What shape? You know what shape? Because it's not as curved as I want it to be, that would be on the verge of putting too much solder in there, but it is definitely, the important things are, it is definitely fully connected to all the copper around it, right? It is definitely connected to the resistor, and it is not connecting to this part of, it's not connecting to any other components on the circuit. So for functionality wise, it's fine. If I want to do it neater and be more efficient with my solder, I should have put slightly less solder in. So it's all about improving your process. So I'm going to go and solder the rest of the. I'm going to keep soldering. Now I don't know how to speed up this particular stream part way through, so we just get to listen. And this is going to be a long video, but I might put some timestamps in it to uh, do the individual parts, so you can clip to see how I solder individual components. That'll probably be fine. Actually, I'm gonna pause the video here, and then I'll make another video where it's be continuing doing the soldering, and so then we'll do all that one. I'll do a timestamp on all the individual group of components that I solder that we can go through. That way, this video you can redo this video just to see the introduction of how to solder the basic 4 steps. All right, we'll see you then.